So, you're building with large language models, and you know the deal. Your app is amazing, it's powerful, but man, it can also be slow and pretty expensive. Well, today we are going to fix that. Does this question hit a little too close to home for you? You've built this incredible thing, but every time a user sends a query, another request goes out to an API, and you can practically hear the meter running in the background. And don't even get me started on the latency. Okay, but what if I told you there's a way to slash those costs and make your app feel lightning fast? I'm talking seriously dramatic improvements. This is the promise of projects like GPT Cache, and we're about to break down exactly how you can get there using the power of caching. First things first, let's get on the same page about the core problem. Every single time your app calls an LLM API, you're paying for it in two ways. You're paying with money for the tokens, and you're paying with time while you wait for the response. Now, when you're just testing things out, it's no big deal. But once you go to production, that becomes a huge, huge bottleneck. So let's start with the most basic solution out there. This is step one on our caching journey, the good old exact match. The idea here is super straightforward. A user asks a question, we save that question and its answer. If another user comes along and asks the exact same question, and I mean character for character identical, we just hand them the saved answer. No API call needed, it's fast, it's cheap, and it's simple. But here's where this whole thing just falls apart. Look at this table. The first query, a perfect hash hit. Awesome. But the second one, just with a lowercase h and no question mark, is a total miss. The third one, which asks the same basic thing but for Gmail instead of Outlook, also a miss. You can see how fragile this is. So yeah, the bottom line is this method is way too rigid for the real world. I mean, human language is messy, right? We use different words, different phrasing, different punctuation, all to ask for the exact same thing. And exact match caching, it just can't keep up. We need something a lot smarter. So let's level up. We're moving on to our next level of sophistication, template caching. Now this is clever. Instead of caching the exact phrase, we create a template. We spot the specific things in a query, like a product name or a person's name, and we swap them out for a placeholder. So, how do I reset my Outlook password becomes something like, how do I reset my app name password? And you can see right away how much better this is. Our template can now handle a query about Gmail, no problem. That's a hit. But take a look at that second example. The user says, change my password instead of reset my password. The intent is identical, but the syntax is different, so it's still a miss. And that's our new problem, isn't it? We've gone from matching exact characters to matching the structure of a sentence, but we're still not getting the meaning behind the words. To do that, we have to take a really big leap. This brings us to level 3, semantic caching. And trust me, this is where things get really, really cool. So how in the world do we get a machine to understand that update my password and change my password are basically the same thing? Well, the answer is kind of wild. We turn words into numbers. This diagram shows you the whole flow. When a new question comes in, the system uses an embedding model to turn it into a vector. You can just think of this as a long list of numbers that acts like a mathematical fingerprint for the sentence's meaning. It then searches the database of all the other fingerprints it's seen before to find the closest match. If it finds one that's close enough, boom, we've got to cache it. And just look at the results. The first query uses totally different words, a different structure, but because the meaning is so close, it's a hit. That's incredible. But what's just as important is that the second query about Gmail is a miss. The system is smart enough to see that even though the meaning is similar, it's not the same problem. It's got an extra logic check to stop it from making those kinds of mistakes. This right here is the secret sauce. It's a big phrase, bidirectional entailment. But the idea is actually pretty simple. After it finds a similar query, it does a quick logic check. It asks two questions. 1, does the new query logically lead to the old one? And 2, does the old one lead to the new one? Change Outlook password implies update Outlook password, and the other way around. But update Outlook password definitely does not imply update Gmail password. This is the step that stops you from giving a user the wrong answer. It's absolutely crucial. Okay, so we've got these flexible templates and this powerful semantic understanding. What happens if we put them together? Well, you get what is basically the ultimate caching model. The hybrid model really is the best of both worlds. It starts by using a template to generalize the query and pull out those specific entities, like the app name. Then, it does a semantic search on that generalized template. What that means is it can handle a user changing both the variables, like asking about Gmail, and the phrasing, like saying, I need to change, all in one shot. It's just incredibly robust. Now, I know what you might be thinking. This all sounds really powerful, but also kind of complicated to build from scratch. And you're right, it is. But the good news is you probably don't have to. You could absolutely build one of these systems yourself, and it would be an amazing learning experience. You'd have total control. But let's be real, for most production apps, using a pre-built, optimized solution from a framework is just going to be faster, easier, and a lot less of a headache to maintain. In fact, a lot of the tools you're probably already using have caching built right in. Frameworks like LangChain have caching modules you can just drop into your project. And the big providers like OpenAI even have their own caching on the server side that works automatically, as long as you know how to use it properly. And to really get the most out of these systems, you've got to play by their rules. For OpenAI, that means being really deliberate about how you structure your prompts. You always want to put your static stuff, your instructions, your system prompt, right at the beginning and put the dynamic user input at the very end. And don't just take my word for it. This quote from OpenAI's own documentation tells you exactly why. Their system works by matching the prefix, or the beginning, of your prompt. So, if the start of your prompt is always the same across many users, your odds of getting a cache hit go way, way up. And that saves you time and money every single time. So, as we wrap all this up, the big question really comes back to you. Which one of these caching levels does your project actually need? Maybe a simple exact match is good enough, or maybe you need that sophisticated hybrid model. The right choice is all about your specific use case. The key is to think about it, analyze what your users are doing, and pick the solution that's going to make your app faster, cheaper, and just plain better for everyone.